In this section, we're going to solve some equations that involve decimals. Now, I want to remind you of the addition property of equality that says we can add the same amount to both sides of an equation, won't change the solution set, and the multiplication property that says we can multiply both sides by any non-zero number, and that also won't change the solution set. Now, we're going to alter this multiplication property just a little bit when we work with decimals because we want to use a little bit of division, and division is multiplication by the reciprocal, so it really still is the multiplication property, but you'll see what I mean in a minute. Let's look at our first problem. So for problem 1, we have x minus 0.45 equals 0.32. Now I want to do just what I've done previously with solving equations, and that is isolate this variable on the left side of the equation. To do that, I want to get rid of this 0.45, so to do that, I'll add its opposite to both sides of the equation. X minus 0.45 plus 0.45 equals 0.32 plus 0.45. So you see I've added 0.45 to both sides of the equation. This side now is x plus 0, which is just x, and this side will be when I add these two. Let's see, 2 plus 5 is 7, 4 and 3 is 7, so 0.77, and the equation is solved. So to solve this equation, I use the addition property. I simply add the opposite of this number to both sides of the equation. That gives me my solution. I have just one x is equal to 0.77. Let's look at our next example. So I have 0.5n equals negative 0.4. Now, I have 0.5n on this side, and what I want is just 1n. Now, normally I would multiply both sides by the reciprocal of the number in front of n, but it's actually just as easy when I'm working with these decimals to divide both sides by the number in front of n. So dividing by 0.5, remember, is exactly the same as multiplying by its reciprocal 1 over 0.5. So instead of multiplying by the reciprocal 1 over 0.5, what I do is divide by 0.5. Let's finish the problem. If I do that to one side of the equation, I have to do it to the other side also. So here I have 0.5n divided by 0.5. That is just n. And on the other side, I have negative 0.4 divided by 0.5. If I multiply both numerator and denominator of that by 10, I'll end up with 4/5. And if I want to, I can change that to a decimal as negative 0.8. If I change 4/5 to a decimal, it's the same as 8/10. So either way you want to write the answer, as a fraction or as a decimal, the answer will be negative 0.45 or negative 0.8. So a little variation on the multiplication property of equality. We divided both sides by the number in front of x, or in front of n here, to get just n by itself. Let's try another one of these. So problem number 3, we have 4x minus 4.7 equal 3.5. I want to isolate x on the left side of the equation. I'm going to use my addition property first to add 4.7 to both sides. So I have 4x minus 4.7 plus 4.7 is equal to 3.5 plus 4.7. So there I've used my addition property to add 4.7 to both sides. On the left side, I have 4x plus 0, which is 4x. And on the right side, I have, let's see, 7 and 5 is 12, carry the 1. 3 and 4 is 7, and 1 is 8. So 8.2 when I do that. Now, the next step here, I would multiply both sides by 1/4, but instead what I'm going to do is use that division property and divide both sides by 4 instead. So I have 4x divided by 4 is equal to 8.2 divided by 4. So x is equal to, let's actually do this division. 4 divides into 8 twice. 0.4 into 2 0 times, and then if I was doing this long division, 4 into 25. So I end up with x equal 2.05 when I divide both sides of this by 4. Now remember, dividing both sides by 4 is exactly the same as multiplying both sides by 1/4. So I actually am using that multiplication property of equality. Here's our next example. I have 0.1x plus 0.5 times the quantity x plus 8, and that's equal to 7. Let's simplify each side first by using that distributive property. 0.5 times x is 0.5x. 0.5 times 8 is going to be, let's see, 5 times 8 is 40. And then with the decimal point in the correct place, it'll end up to be just 4. And that's right? Because this is 1/2 times 8 is 4. Now I'll simplify. 0.1x plus 0.5x is 0.6x plus 4 is equal to 7. I'll add negative 4 to both sides of the equation. Let's not actually show that work, but just the result. When I add negative 4 to both sides, that side is 3. Next, I'm going to divide both sides by 0.6. And so I end up with just x is equal to 3 divided by 0.6. Multiply the top and bottom of this by 10. That will be 30 divided by 6. And then 30 divided by 6 is 5. So the result is just 5. And I can check that if I want by substituting 5 for x back in the original equation. If I work this all out, this side turns into 7 just like this side. Let's try a couple of word problems. Problem number 5, we have a car rental company charges $10 a day and 16 cents per mile for their cars. If a car was rented for 1 day for a total charge of $23.92, how many miles was it driven? So we want to look at this problem. We'll use our blueprint for problem solving. When we see what items are known and what items are unknown, we have that the car company charges $10 a day, 16 cents a mile. We know it's rented for 1 day. We know the total charges are $23.92. What we don't know is how many miles it was driven. So let's let x be equal to the number of miles the car has driven. Let x equal the number of miles driven. Now I want to write an equation in x that describes this situation. So first of all, the car is rented for 1 day and that charges $10. So as far as the total amount of money that we spend, it's going to be $10 plus it's going to be 16 cents a mile, and I've driven it x miles. So 0.16 times x will be the total charge for mileage, and that will come out to be the total charges of $23.92. So $10 a day, and I rented it for 1 day, so that's that 10. Plus 16 cents a mile times the number of miles driven, that gives me the total charges, which is $23.92. Now this equation involves this decimal right here and this decimal. You can solve it just like we've solved the equations previous to this. That will give you your solution, which will be the number of miles that that car was driven. I'm not going to go solve that right now. I'll leave that up to you. Let's look at our next problem. It says Mary has $2.20 in dimes and nickels. She has 10 more dimes than nickels. How many of each coin does she have? Well, as far as using the blueprint for problem solving, we know that the total amount of money is $2.20. We know that there's just dimes and nickels, and we know that she has 10 more dimes than nickels. Okay, so what we want to know is how many of each coin does she have? We don't know the number of nickels or the number of dimes. So let's see. She has 10 more dimes than nickels, so let's let x equal the number of nickels. So if I have x nickels and she has 10 more dimes than nickels, then x plus 10 equals the number of dimes. So you can see if I let x be the number of nickels, since there's 10 more dimes than nickels, there's going to be x plus 10 dimes. Now what I want to do is go back, read the problem again, and write an equation that describes this situation. So I have x nickels and x plus 10 dimes. Well, every nickel is worth 5 cents. Let's just work in terms of cents. So 5 cents times the number of nickels is going to be the total amount of money in nickels. And then 10 cents times x plus 10 is going to be the total amount of money in dimes. Well, the amount of money in nickels plus the amount of money in dimes has to come out to be the total amount of money, which is, I would write 2.20, but since I'm working in terms of cents here, I'll write 220, since I'm working in terms of cents, so 220 cents. So let's see. Total amount of money in nickels plus total amount of money in dimes, that comes out to be the total amount of money, $2.20. Okay, so I'm not going to solve this problem. I'll leave that up to you. But what we have here is two different things that we're asked to find, the number of nickels and the number of dimes. If we let x be the number of nickels, then we write the number of dimes in terms of x, and that comes out to be x plus 10. We have the number of dimes, the number of nickels, then we have the value of those dimes and the value of those nickels. 5x is the value of the nickels, 10 times the quantity x plus 10 is the value of the dimes. that has to come out to be the total amount of money that she has in dimes and nickels.